yesterday?
Rise up.
Rise up?
Like what is rise up? And then
okay, what is rise up?
we learned how to rise up. It means reports, interface, and C means conversion, like from non-SAP to SAP.
Okay.
And then F is forms, W is workflow, or it can be, there was other word, something like Vedi Pro.
WebDen Pro.
WebDen Pro.
Okay. Okay. Right. Good.
And now
Right,
it's
so
Fiori, I think.
that's fine. What else? Technically, what did you learn? Guys, this is open to everyone. So everyone can speak. So no restrictions. So the reason why I'm asking is how good you are, at your side. So daily we will have a revision for 5 minutes of the previous classes. Okay. Yeah.
Declaring variable.
Declaring variables.
Then
Okay.
taking inputs.
Parameters. Very good. Okay. Yeah, that is declaring variables is data types.
Selection screen.
Transaction
Selections.
codes.
Transaction codes. Okay. Selection screen. Okay.
And then how to use text elements.
Very good. Text elements. And selection text. Right?
Debugging.
Yeah.
Debugging. Very good. What else?
Chain operator.
Chain operator. Okay. Also, the backslash, right?
Yeah.
Backslash for printing the statements on the next line. Okay. And we also learned how to color.
Yes.
And we learned how to put underline, like line separation. Okay.
And
Anything
how
else?
to create a workspace and basic program.
How to create workspace. That is very important. Like GUI related, SAP GUI stuff. Correct? Connectivity to SAP. So these items we have learned, and we also learned ABAP program naming convention. How do we create a program? Yes. Creation of the program, saving the program, activating the program. Okay. We also learned how to save the program in the local object. That's a package called, right? There is a package called local object. Local object. We learned putting this program into a local object. So these items we learned yesterday. Most of the things like whatever that you are seeing now over here, we have covered almost all items in our yesterday class. Anything else that is left? Okay, I think this is what we covered in yesterday's session. So in total. So like I would like to know how many of you started connecting to SAP. Did you guys install? Those who have already installed, that is fine. So for the new people,
Yes, sir.
Yes, I did.
You did. You installed SAP in your system.
And created a workspace.
Very good. Connected to the system?
Yes.
Did you log into SAP?
Yes, I did.
Okay, very good. That's fine. So guys, as I told you, like practice is more important. Without practice, it will be like little difficult. So always keep practicing as many number of examples as you can. Also, you can Google for the stuff whatever that we have learned yesterday. You may get even additional concepts, or you may get some additional code also. Okay, so that should be your basic things. I'm explaining you all the things technically, but if you want to be advanced on yourself, also you can depend upon Google. Just Google it, you'll get the lot of stuff, materials, blogs available on the web. You can refer to any one of that, and you can make some notes of that, and also you can share over here if something is new that you are learning. You can share it over here on this platform as well. Okay, fine. So hope we are all clear on these contents what we have learned yesterday. So let me go into the next topic today. So which is related to few things I did not explain yesterday. So let me cover that also. So we call SAP as SAP R3 application. SAP R3 application. When we say R stands for real time. When we say R stands for real time. It means real time data. When we talk about three means like your, when we talk about three means it is application server, presentation server, and database server. So I repeat again. So let me put that over here. Give me a moment. Yeah. So when we say R3, is the font, R3, R stands for real-time systems, and 3 stands for application server. Okay, so let me put this one first. Let me put this first. Presentation server, application server, and database server. Okay, so these are the three servers we talk about when we say about 3. So what does this mean? This means presentation server means the screen what you are seeing, the input, output, the screen what you are interacting with will be coming under the presentation server. That will be coming under the presentation server. Next, you provide some input. You provide some input. Let us suppose this is my screen. So here on the screen, I'm trying to enter some data. I will put some data over here. Okay, I put some data over here. Then what happens? I press enter. You say you press enter. So when you press enter, what happens? Next thing, immediately the request, whatever you provide here in the first screen, that request will come to the next level, next layer. Very simple. Okay, it comes to the next layer. The next layer is the application layer. Next layer is the application layer. So in the application layer, what happens? All the logic corresponding to your business, whatever is there, that gets executed. So all the business logics corresponding things will be executed over here. And if your request is if your request has something to do with the database, if your request has something to do with the database, then it also will go and hit the database server also. It will go and hit the database server. It means, let us suppose you're trying to extract some records of an existing employee. Let us suppose an existing employee. So what happens? You will provide the input over here. That input provided will come to the application layer. In the application layer, it tries to process the data, whatever that you have entered in the presentation layer. So this data is relevant to the employee who is already existing in the organization. So where can we see the data? We see the data in the database. So in turn, this data, this request will come and hit the database. So this is how the connection between the systems of R3 is shown here like this. So every time there will be like connectivity between these systems. So there will be a request coming from presentation layer to application layer and to database layer. Again, a response will go back again. A response will go back from the database layer to the presentation, database layer to application, and from application to again presentation layer. So this is how you will see the flow of the data mutually among all these systems available in SAP. So it's not only in SAP, in most of the areas, this is the basic thing which is being followed. Not only in SAP, but in most of the areas it will be followed. But also we are just remembering that this concept is available even in SAP also. So that is what we say the concept of R3. If anybody asks in interview like what is R3, it's R which stands for real-time systems, and 3 means like presentation server, application server, and the database server. And you can explain whatever that I told you now here. So this is like a simple explanation. You can you can brief it very easily as per your convenience. Okay, so that's about R3. So now coming to the next point. Okay, so if you see this, if you see this slide, you can see here on this R3 platform, you see the basis. So basis is the team or the SAP team who will be especially like configuring the system. Configuring is nothing but they are the infrastructure team. They will be helping building the SAP systems. And if you observe here, you can see different models here like SD, MM, PP, QM, PM, HR, IS, WF, PS, AM, CO, FI. Likewise, all these modules are like, if you can see this slide, all the modules are around this basis component. It means all these modules are tightly integrated. Tightly integrated means if something happens in FI, we can get that details in like some QM. If something happens in SD, then the change will be reflected in all the other modules, in all other respective modules. If something is made, if there are some changes in MM, then relevant to that changes, you can see that change in different modules also. That is the reason why we are calling it as R. R means real time. Anything that happens immediately, that effect will be there on the other modules. Okay, so that's about R3 understanding. Okay, so next, coming to the landscape, SAP landscape. So what does the landscape tells you about? Landscape tells you about the servers, the availability of the systems in your project. Availability of the systems in your project. What do you mean by that? It means generally in every project, we will have a development server, we will have a quality server, we will have a production server. This production server is the final server where all your developments or configurations will go and sit. Okay, finally all the developments or the configurations functionally will go and sit, and this is the system which is responsible for live data. For all the business transactions which are happening will be captured in the production server. That will capture in the production server. It means it is like a real-time system. Very simple. Okay, so when we talk about development, in the development, we generally do the developments. For example, yesterday we have created one program. Let's take an example of that program. That program we created in the development and we tested it. It is fine, the working fine. What we will do in development, we will have very less data. We will have very less data. So in development, due to this less data, what we will do, we will move the transport to quality. Okay, we will move the transport to quality. So let me explain you that clearly. So I'm taking this slide. So I'll put it over here. Okay, then, so let's see this. So in development, you'll have less data. Data will be always less. So that is the reason why what you will do, if you're talking about the program, that program from dev, you will move to quality, to the quality system. Because in quality system, you will have good data. Data is maintained in the, or you can say good data or data is rich in a quality system. So because for our testing, we need data only, right? For testing, we need data. So data can be in a different ways. Who will prepare this data? So this data will be available by default. We will load the data into SAP environment from non-SAP systems, or the functional person will be preparing the data. Functional persons or functional consultants will be preparing the data as per the requirement. Okay. So functional persons will be preparing the data as per the requirements. Fine. So now they will perform the testing in QA, and if it works well, then immediately what they will do, they'll move this program from again to production. They'll move it to production. In the production, there is no concept of testing. Directly executing the program. We directly execute the program. That's it. We directly execute the program because it is a live environment. If you think there are any issues reported in production or in quality or in production, let us suppose, then you are back to development. You'll be back to development, fix the issue, test, and move changes to QA and then to PRT. You'll do all these activities again. So you will make changes. Okay. So once when there is some change, when once there is a issue found, then again you'll be back to the development. You'll be again back to the development. So it means anytime what happens, if you're doing a program, you're moving to the quality, you are testing it again here. If no issues are found, you'll go to the next level. If you are finding some issues in the quality, let us suppose if there are any issues found here, then what you will do, you are again back to development. So that issue you will fix it here. Again, you'll go to the quality. You test it here. If it looks good, it goes to the production. So production is your final system, and the production is the final target system. So this is what the SAP landscape tells you about. In some projects, the landscapes may be different. Sometimes what happens, this quality is there, right? They will divide it. For example, they will divide it to some like a quality, like a test 1 system, or they will make it to some test 2 system. Okay. So likewise, they will make some changes. They will add some other systems for extra or additional testing. But finally, the overall understanding of the landscape is like the availability of the systems in the project where your developments are made and moved to the target environment. Okay. So this is about the system landscape. Are we clear? Any doubts on this?
No doubt.
Okay. Fine. So now let's move to learn technically. So in today's session, let's learn about the control statements. Example of the control statements. We'll learn about structures, and we'll try to learn, if time permits, we'll try to learn about internal tables. Okay, let's go into the control structures. So let me open SAP. So what I'm trying to do now, I'm trying to create a program again, SC38. I'm saying Z ABAP underscore batch 1 underscore, I'll say control underscore stmt. Okay, control statements. Click on create. Say ABAP program. Control statements. Type executable. Click on save. It will ask you for the package. Okay, just click on local objects. Okay, so this is your program. Right. So what I'm trying to do now, when we talk about the control statements, we learn about few things over here. So first of all, I will declare a variable. I'll say LV underscore. I'll say some subject 1, type I, and you can assign the value directly over here. Value value some 80, give some value as 80. LV underscore subject to type I, value some 90. Okay. So now let us learn about the first thing is if condition. I would like to compare the marks between two subjects. So what I will do, if, see when you type if, you see on the top immediately, there is a small pop-up coming, correct? You can see that there is small pop-up coming. So what you do immediately, when you type, immediately press a tab key. Immediately press tab key. I'm repeating again. If you see that pop-up, immediately press tab key. It means every if statement ends with end if. So the structure will come directly, or you can type it. If end if, you can type it. But sometimes what happens, you may miss typing end if. That is the reason why the best practice is say if and just hit tab. You'll have if you'll have an end if. So every if should end with end if. Now, what is the condition? We are trying to check between two numbers. So if this LV is subject to 1 greater than symbol. Okay. So we will use the symbols like in the mathematical operations, like greater than means we'll say greater than, less than means we'll say less than. Or if it is like a less than or equal to, let us suppose, then for that we will say LE, less than or equal to. If it is greater than or equal to, then we will say GE, greater than or equal to. We directly use this two letters, LE, GE. If it is greater, also you can say GT, greater than. If it is lesser, also you can say lesser than. Okay. So for this GT, LT, we can use these symbols. But for less than or equal to, greater than or equal to, you have to use LE, GE. Okay. Just try using this. So first of all, I am trying to use subject 1 greater than subject 2. If this condition is true, what I'm trying to do, I'm saying write, okay, what I will say, subject 1 marks are greater than subject 2. Okay, subject 1 marks are greater than subject 2. Just have a pretty printer. Just activate your program. Just execute. You're not seeing any output because subject 1 marks are not greater than 90. Is it true? 80 is greater than 90? 80 greater than 90? No. So what happens? This statement is false. This will not execute. For that, what you need to write? You need to write another statement. If this is not true, what should happen? If it is not true, what should happen? So here we write else. If, else, and if. In the else condition, we say write subject 2 marks are greater than subject 1. Reverse to the first statement. Are we following? Activate it and execute. Now you will see the output. Subject 2 marks are greater than subject 1. It means which statement executed? Else statement executed. Okay. For you to understand, let us put a breakpoint. Okay. And guys, try yourself debugging the program as and when required. Just execute it. Execute it. And when the debugger screen comes, okay, so you just close this one. This ABAP and screen stack is there, right? Just close it. You will find a cross tool button. Close that. It gets closed. Sometimes what happens, this is there, right? This screen will come here at the bottom. It will come here at the bottom. It will come here at the bottom. So no need to panic. You will have this horizontal, vertical things. So if you click on that, you will be able to manage it. You'll be able to, you can manage it. See, this is what I'm saying you. It comes like this. When it comes like this, you have something called here maximize vertically. Maximize vertically. So if you click on this maximize vertically, it comes onto your right side screen. To the program, it will be visible on the right side. Now it looks good. So now double click on this. You see sub 1, sub 2, 80, 90. And guys, also observe psi-sub C. Try to observe this field. This is called as a system field. SY stands for system. Sub C stands for whether it is success, that particular statement is success or not. Psi-sub C will tell you whether that respective statement is success or fail. If it is success, this will have value 0. If it is fail, this will have value other than 0. This is the system field. We will learn more about this later, but try to observe this. Now I press F5. when I press F5, you see from if condition, it jumped onto the else condition because the first condition is failed. First condition is failed. So first condition failed. That is the reason why it came inside this. So just execute it. You'll be able to see the output. Are we good?
Yes.
Yes, sir.
Yes.
Okay. So likewise, if you have some other variables over here, let us suppose I'm taking an example of these subject marks, but later we'll look into some other things later. Okay. So now what you need to do? You need to compare. You need to compare 3 fields. Okay. You have to compare how many fields? 3 fields you need to compare. Now subject 1 is there, subject 2 is there, subject 3 is there. So what do you do here? What do you do? We have to compare subject 1 with 2 and 3. So what I will do, I'll copy this. Let me comment this and let me go here. Here I will say LV subject 1. I need to compare that with other. LV subject 1 greater than subject 2. I will say and LV subject 1 greater than subject 3. Subject 3. You see, I am using the AND operator here. It means I'm comparing subject 1 with subject 2 and again subject 1 with subject 3. So I will say subject 1 marks are greater. Simple. Is it clear? Any doubts in this?
No. Mm.
Any doubts in this? So I'm using this parenthesis here in order to make this condition as a single condition. This is a single condition. So that is the reason why I'm using it as I'm using this brackets or this parenthesis over here. Okay, so now this is done. What is the other thing that we need to do? This is one if condition. The next if condition is I'm comparing subject to 2 marks with subject to 1. Again subject to 2 marks with subject 3. Correct? Subject 2 with subject 1, subject 2 with subject 3. I say subject 2 marks are greater. Simple. And again, now 1 compared with 1 compared with 2 and 3, 2 compared with 1 and 3, and 3 should compare with 1 and 2. Okay. We will say here subject 3 marks are greater. Now activate it. You're good. Now let's put a breakpoint over here. Now execute the program. Let's see what happens over here. Subject 1, subject 2, and subject 3, 80, 90, 70. Okay. So first condition fails. 80 greater than 90. No, it itself failed there. The very first condition only it's failed. Now next thing. Subject 2 greater than subject 1. 90 greater than 80. True. 90 greater than 70. True. It means subject 2 marks are greater. You will have that statement printing in the output. Okay. It means this is successful. This gets printed in the output. Let us also try with 3. 70 greater than 90. No, it failed. It will fail. So finally what you will get? Subject to 2 marks are greater. Okay. So this is how we compare the values between the variables. I'm telling you an example of the usage of the if condition, but real speaking, we will have, we are just trying to understand the use case. That's it. But in real time, also we will have the conditions. We will have the conditions like this only. Okay, but not with subject marks, but with a different field values related to the SAP table fields. Okay, are we good with this?
Yes.
Any
Yes.
confusion? Any confusion to anyone over here?
No.
Okay. So the same thing I am writing here. If for three statements, right? What I can do, I can avoid writing these three statements. What I will do, I'll remove this end if. I'll say here else if. Remember, I say else if, and I'll remove this end if, and I'll say one more else if. That's it. Yes, see? Okay, same thing. Previously, what I did, I used for every condition, I used one if statement. So I'm trying to avoid using that if statement multiple times. So that is the reason why if this true, execute this statement. Else if, check this condition. If it is true, execute this statement. Else if this condition is true, then execute this statement. Simple. Understood? So now activate this. You will have the same output. You will have the same output, but the way you are using is different. I am using here else if. I'm using here else if. So what we have learned in the if condition, we learned how to write a condition. If, else, end if, then again if with end if, again if, combination of else if. So this is how in real time we will make usage of the if condition. Are we good? Any confusion, any problem in understanding this?
No, it's clear.
Okay. Others? Fine. So now what I will do, let me comment this code. Okay. This is all for if condition. Now I'll go for a new thing. I'll say, so this is completely for if condition. Guys, if you want to refer to this program, you can refer it later when you start your practice, just for your, only for the reference. Okay. Now let us try to understand. Let us try to understand. Now what I will do, I'm taking parameters p underscore month type I. Okay. I'm taking a parameter called p underscore month type I. So I'm trying to give the name of that parameter as, go to selection text. Okay, I need to activate it first. I did not activate it. That is the reason why it is not showing in the text elements. So you see this, I'll say enter month. Back. Okay, it looks like this. Enter month. So what I will do here, there is a concept called case. There is a concept called case. This case concept is especially used to avoid the number of if conditions. See, like you are using your if, else if, else if. Likewise, there can be many number of if and else if combinations. So to avoid this, we are simply using this. So I will say case p underscore month. When one, I'll say write January. I'll tell you how the output looks like. When two, say February. Likewise, when others, and also you can include as many number of when as possible. When 3, you say it as March. So you can include up to, you can include any number of when statements over here. There is no restriction. So I'm stopping up to here. When others, say other months. Simple. Okay. Just have a pretty printer on this. Just try to activate your code. Try to activate your code. Now execute. Enter the month as 2. Execute. You'll see the answer as February. Go back. Give the value as 1. Execute. You see the answer as January. Give the value as 3. Execute. March. If you give the value as 4, execute, it will say other months. Okay. So try to put a breakpoint over here and try to execute and see. I'm giving the value as 3. Execute. You see P underscore month. It is 3. Now press F5. It stopped at when 3. It stopped at when 3. It means it checks case. Case means what is case here? 3. It means corresponding to this month, what is that when statement available? Is there anything available with a 3 here? This is 3. This is value 3. Do you think that same 3 is available over here with when statement? Yes, it is available. It means the answer is this. So execute it. You'll get the answer. Are we clear? This is a very simple way of using the case statement. So here in this case statement, you can write your logic. Any logic you want, you can write it. It's not only specifically meant for writing these statements, but if you have any business logic, if there is any logic that you need to build, you can build that as well here. In everywhere, in every section, you can build your own logic. Okay? Everywhere in every section, you can build your own logic. So it doesn't mean that you cannot do other items. You can build your own logic here also. Are we good?
Yes.
Okay, so
Yeah.
have a practice of this case statement also. So this will be useful to you in your real-time environment for sure. Okay. Next. So after this, we'll try to learn about loops. This is all about the parameters. This is all about parameters, and we try to learn about looping concept or loop structures. We'll try to learn about loop. So in the loop, you have do times and do. This is like an unconditional loop. This is like a unconditional loop. Okay. So what we will do here, this is not based upon condition. That is the meaning of the unconditional loop is. What does this mean? It means, see, I want a loop to repeat for 10 times. What do you mean by loop? Loop means it's like a kind of a iteration. It is a iteration. You want to repeat some statements. You want to repeat some set of statements. You want to repeat set of statements. You want to repeat set of statements. So if you want to repeat the set of statements, you can use the concept of loops. In the loop, we have two things. One is conditional loop, and the other one is like unconditional loop. Unconditional loop. Okay. So first we will try to focus on unconditional loop, and for the conditional loop, when time comes, I will let you know about that conditional loop. Okay, so now let us say here, how many times I want to repeat the loop? I want to repeat the loop for 10 times. You give that number and say here, write, say hi. Let us suppose. Okay, activate it. Just execute it. Did we put breakpoint? No, let's not require breakpoint. Just execute it. You see, how many times is the loop? You see that hi statement printed? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times it has printed. I'll say this for 100 times. Let us suppose. Let me give for 100 times. Okay, execute it. You see, it printed for 100 times. Totally, it printed for how many times? 100 times. So you have to decide on yourself how many times you have to repeat the loop. How many times you have to repeat the loop. Okay, so yesterday we have seen one example of the tables, right? We have seen the example of tables. So the table concept yesterday, like 10 into 1 equal to 10, 10 into 2 equal to 20. That concept you can bring over here. That concept you can bring over here. So how do we achieve that in this concept? That I will explain you now. So what I will do, I'll say data LV underscore, I'll say table type. Okay, I will take parameter. I'll take parameter p underscore tab type I. I'll take the parameter type I. It means I will put the table number like 10 or 20, whatever it is. Then what I will do, I'll take one variable LV underscore value type I. Okay. So what was the logic that we have seen yesterday? Now I'll say do 10 times, do 10 times, 10 times it will repeat. So in this case, what I'm saying, LV value equal to, first of all, the value will be equal to 1. The value is equal to 1. So what is our understanding here? We also take one more LV underscore results type I. LV result equal to the table into, what is that? Table into LV value. LV value. So like 10 into 1, 10. So I will say, right. I'm just trying to put only the result. We will see only the result first. We'll put the result. Then I will try to increment the value LV equal to LV plus 1. Let's try to increment the value. Just try to understand this. I declared this loop for 10 times. And the LV value I gave it as 1. LV result is this. LV result equal to the table number that you input into the value 1. It means 10. You gave the value as 10. 10 into 1 is the result 10. The 10 will get printed over here. I'm incrementing the value. LV value equal to LV value plus 1. This becomes 2. It goes in the next iteration. It goes here. It will say 10 into 2. This become 20. 20 will print. It will become 3. And it checks. 10 times it will repeat, right? So 10 times it will go internally in this loop. So now I'm activating this. First we'll see the output. Then what is the error?
LV result, right? LV result.
Okay. I gave only results.
Yeah.
Yes. So we give LV result. First, let me execute this. I'll give the table enter value for the table. Activate it. Go back. Executes. I'll say 5. executes. You see, 5, 10, 15, 20, up to 10. 5 into 10, you have the values in the output, correct? So let us see. I'll give for 8 and executes. It's very fast. Try to put a breakpoint and you will understand it very easily. I'll say 6. Execute it. Now let us see how the data is flowing. LV value, LV result. Now in the beginning of this line, the value is 0. Now it is 6 into 1. Your result will become 6. 6 will print in the output. And let us see what is the value. Value will become, press F5, it becomes 2. Now it goes back. Press F5. You see, it goes back to the loop. And again, it will try to say 10 into 2. Now you see the result value. Result value will change to 12. The 12 will get printed in the output. Now the value, LV value will change to 3. You see, change it to 3. In the next iteration, 6 into 3. It will print 6 into 3. See the result? 18. So likewise, this loop will repeat up to how many times? 10 times it will repeat. It will repeat how many times? How many times it will repeat?
10 times.
10 times. But how do you know? How do you know we are in which loop? How do you know that you are in this loop? Second loop or first loop or third loop or fifth loop? I'm talking about the iteration. How do you know that you are in the respective iteration? How do you know that you are in the respective iteration? It means the fifth iteration or fourth iteration. Yes. We have a system field called psi-index. Psi-index. This will tell you about the number of iteration. You see, we are at with which iteration now? Fifth iteration. What is the value of results? Press F5. See, 6 5s are 30. It means the fifth iteration. We are in fifth iteration. Now press F5. Press F5. You can see here, you are in sixth iteration. You are in sixth iteration. Are you following? The psi-index is a system field. System has its own, SAP has its own predefined field. These are not defined by us. See, that is the reason you are not seeing here. Psi-index. Psi stands for system. So this field, this value is available in the runtime. The values for the system fields are available in the runtime. So what you can do here? Very simple. Instead of using this, I can avoid this. And instead of this, what I can do, we have already a system field. I will say psi-index. Psi-index. Just activate this. And you try, I'm putting a breakpoint over here. Execute this. I'll say my table name as 4. Okay, now you see psi-index value. What is the value? It is 1. You see, 4 into 1. Let us see the results. 4 into 1, 4. 4 will print. Next, what is the value of index? Automatically it is changed to 2. We did not increment it. By default, it incremented. That is what the advantage of the system field is. Now, the complexity is little reduced, right? Instead like multiplying here, that is a common statement over here. But this increment statement, we avoided it because psi-index is incrementing by itself. Okay, in the runtime. So now say press F5. You see, now what is the psi-index value? It is 3. Okay. So now press F5. You see the result as 12. 4 3s are 12. So likewise, when I execute this, the psi-index value will again become 4. Again, 4 4s are 16. Okay. So you will have the result like this. The same. The only one thing is what we changed is we commented this line, this incremented line, and we are using only the psi-index. It's up to you. Whether you want to follow this or you want to make use of the system field, it's up to you. Okay. Are we good?
Yes.
Yeah.
Okay. So let us suppose I want to give this as 15 times and I want to break. If psi-index equal to, let us suppose 11, then I want to break this loop. I will say exit. Okay. This will become conditional now. In the unconditional loop, I am putting some condition and I am breaking this loop, breaking the iteration. I am breaking the iteration. So what happens? Let us see. Execute it. I'll give the value as 3. Execute. You will see what is the value here? 30 into 33. It means 11th loop has executed. 11th loop executed. So when it is 11 or when I say when it is 10, we stop it. When it is 10, you stop it. By the time we will have the result printed on the output. So execute it. I'll say this as 3. Execute it. You see, 3 10s are 30. So it means how many times you are printing? You are printing for 10 times. I'm putting a breakpoint. Execute it. Let us see the condition. Yeah, see this index. Okay. See this index value. You can directly execute, guys. You see here. Previously, I was pressing F5. F5 is for only line, age, 9. Now comes 10. Observe here. When psi index equal to 10, what I'm saying? I'm saying exit. Exit means exit from this loop. The meaning is exit from this loop. So when I press F5, you see it goes inside and it comes out of the loop. No, it will not enter into the loop. So no more entering into the loop. Because even though we gave it as 15 times, it executed for 10 times. 11th time, it is trying to enter in, but we used exit, it comes out of it. That's it. Simple. Okay. Clear with this?
Yes, sir.
Any doubts, any confusion, any explanation you need me to do it again? I mean, do you want me to explain anything again over here?
No.
So your silence, I take it as granted that you understood everything.
No doubts.
Oh, okay, that's fine. So, yeah, so we pretty much covered if condition, if else, case statements, and this do loop. Okay, so the next concept we have is structures. So, are we good with this? I'm going to create a new program. I'll say structures. This is very important, guys. Not only this, everything is important. Okay. Now, I'll say I'll try to take some fields. Student information. Let us suppose I would like to take some fields for students. So what I will say, data LV underscore name. I'll say type string. I'll take type string. Data LV underscore class type string. Data LV underscore section. I'll say it has like some 20 characters. Type C. Okay. So if you see this, also I will take data LV underscore address. We'll take it as type string. Just observe here. I am taking how many fields? 1, 2, 3, 4. 4 fields I have taken. 4 fields I have taken 4 times. For the 4 fields, I'm using data, 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 and data. Can we avoid repeating this data keyword? Possible? Is it possible?
Yeah.
How is? You can use chain operator. Okay. So I'm commenting this. Yeah. Can you tell me like how can I use it? Data.
Data. Yes.
Colon. What next?
After
Next, we have to put comma.
Where?
Near
After
string.
colon, we have to put comma.
No. At the end, LV underscore name type string, comma.
Type string, we need to put comma. Okay.
Yes.
Okay. What next?
Remove the full stop.
And remove the full stop.
Full stop. Okay. What next?
And then in the next line, we
We
should
have to
remove
remove the
data.
data.
We have to remove the data. Okay.
And we have to place comma instead of full stop.
Okay. Okay. Yeah. Proceed. Next.
Same for the next line. Removing data.
I forgot.
Place comma
Next.
instead of full stop.
Place comma instead of full stop. Okay. Next.
The last line, we have to only remove data.
We have to remove only data. Okay. What about comma? I don't know. Should I
is
not
the
put
ending.
comma?
No, only full stop.
Only full stop.
Why?
It is the last line.
That's it. Okay. So good. So you understood, right? So that is what the usefulness of the operator, the chain operator. So in a single keyword, we clubbed everything into it, and the last statement is the final statement. I mean, we don't have other variables, so it should end with the comma. That's it. Very simple. Okay. So this is how I declared. And you see, when I put a pretty printer, you see the keywords type aligned perfectly. So always try to put pretty printer. So now what I'm trying to do, I'm trying to put some name, LV underscore name equal to, okay, LV underscore name, I'll say SAP some Ramakrishna, let us suppose. LV underscore class, I'll say it as some BTech CS, let us suppose. LV underscore section, I'll say it as A. Or some 2024 A section, let us suppose. LV underscore address, I'll say it as some Hyderabad. Okay. So I assigned the values. See, this is the data declaration. This is data definition, means we assigned the values. Then here, let's try to print the data. So what we are trying to do, we'll say write student details. Okay. Student details. Color, I will say some 4 or 5, something else. I'll say write LV underscore name, LV underscore class, LV underscore section, LV underscore address. That's it. Activate it. Execute it. You'll see student details, SAP Ramakrishna, BTech, CS 2024A, Hyderabad. Okay. Now, I want to take details of another student. I want details of another student. Let us suppose I'll take Siva Krishna. Then activate the code, execute it. This student details is not required here. In place of that, I will say uline. Activate it. Get it. You see, I have two different student details over here. So this is how we assign the values and we are printing it. Okay. So now the question is this data linked? Is this data interlinked? Do you think this data is linked or not linked? You understood my question? Generally, when we talk about a database, the database, we will have a table. In the table, we will have columns like this, correct? For example, this is a student number, student name, is some section, is address, etc. things. And for this table, we will give some name. I will say the name as some student underscore info. I will give some name. And we will have the records entered over here. We have the records saved into this database table, correct? So it means in this table, when we are saving the data will be like related data. We will have the related and the relevant data. Because it is a database table, it has the data saved inside it, and that will be like relevant to it. But in this case, this is like independent data. SAP Ramakrishna is the record available here in the system. This is like we can see only the data, but there is no relation between these records. This is separate entity and this is like a separate entity. There is no concept of link here because this is not falling under the concept of the database. Not falling under the concept of database, and moreover, this data, whatever you are seeing here, is visible only in the runtime. Runtime means when you're running the program only, you'll be able to see this output. If you're out of the program, you don't see this output. Okay, and when I go back, where can I see this data? This SAP Ramakrishna and this Yogakrishna data, where can I see? Do you have any tables you created to see this data? No, right? There is no concept of table here, right? I am just declaring the variables, assigning the values and printing them in the output. That's it. It ends there itself. Correct? Following? Yeah. So the very first thing that I want you to convey here is we are declaring the variables separately. You are declaring the variables separately. So rather than that, so imagine, just imagine if you have something. Okay, so let me take a screenshot of this. Let me take a screenshot of this, put it here, and let's try to work on this. Let us suppose all these variables are independent, right? All these variables they are declared independent. So variables are declared independent. Have you heard about the concept of structures? Have you heard about concept of structures?
In C program,
Yes.
we have used structures in C program.
That's fine. It can be
It's
anything. I
like
am not
a
asking
template.
only. It is a
It's like a template. Like
for what?
it's used for reusability. Like the students' details, and then we can store multiple students' details, like multiple names under one template.
Mm-hmm.
For
Multiple
example,
names.
name.
No, you cannot store multiple names. Structure will have only one record at a time.
Okay. In C program, we can use multiple times.
In C program, you can use multiple times.
Yeah, but we have to create a new. It's like class and object. We have to create new object every time
Yeah.
for every
Okay.
record.
So the same concept we use here also. So basically, what are we trying to do here? In this concept, you see string, character, and string. So it means what we are trying to do here is in this structure, using structure, we can using structure, we can combine data of different data types. Data of different data types. This is the very first important thing that you need to understand. Data of different data types. You see this string, C. All these things we can club into one single structure. And this holds only one record at a time. Holds one record at a time. And this will be useful in internal tables building. We will learn about a concept called internal tables. We will learn about a concept called internal tables. And this, for internal tables concept, structures are the building blocks. Very simple. Structures are the building blocks. So we'll try to see how we will be using this structure and how can we make use of these fields inside a structure in the same program. Okay, in the same program. So what I'm trying to do now, just I'm copying this. I'll say here data. You see, begin of. For structure, I'm saying struc underscore students. Data begin of. For begin of structure, we have end of structure again. Begin of structure, we have end of structure. These fields we will take inside. We'll take inside. We'll
No. Use chain operator.
Chain operator.
let me align this.
Need to give comma at the end of LV address string.
Yeah, that is a catch. Correct. So this is not ending. Ending is this one. So this is how your structure declaration looks like. You say begin of your structure name, your variables inside this, and end of your structure name. So begin of your structure name and end of the structure name. In the begin and end, you will provide your variable names with the same thing as you are using this comma. First field ends with comma, second field comma, third field comma, fourth field also comma, and in the finally the structure name will have the period symbol, and this is your structure name. Okay, so I'm commenting all these lines. So these lines are no more required. I am just trying to take these values. Now what we will do, for us to assign the values to the structure, we will take structure name hyphen field name equal to the value. Okay, structure name hyphen name equal to value. I will say like Tech India, let us suppose. Again, structure name hyphen field name. What is the field name? LV underscore class equal to, say here some BTech. Again, LV underscore section equal to some A. LV underscore address equal to, let us suppose, Hyderabad. Now I'll try to print this data. Try to print this data. So now I will include the structure name everywhere. Structure name hyphen field, structure name hyphen field, structure name hyphen field, and structure name hyphen field. You see this? Activate it. This execute it. You will not find any difference in the output of the data. The only one thing is the way how you are using it matters. Okay. Now what I will do, I will try to change this. I will try to assign a new value and try to print the new value. Execute it. So first one is this and second one is this. So the understanding is now all these fields are related to a single template which is called as the struct underscore student. Okay, so now instead of declaring the variables openly, we try to put that variables under a template which is called as this structure. And while referring to that variables, we are referring to that structure. Structure hyphen variable, some value. Structure hyphen variable, some value. Structure hyphen variable value. So likewise, we assign the values to the variables inside a structure. We printed that data. We are assigning again a new set of data to this structure and we are printing that in the output. So this is how you will make use of the structures concept in your in ABAP learning, and this is very important because you will make use of this particular structure for building the concept of internal tables. As I told you already, we have something called as internal tables. We will make use of the building this concept for the internal tables. Any doubts in this? So this is pretty clear. Like there is no much complexity, or this is not much complexity involved or included over here. Just the open variables we kept under a structure, and we are just using the structure hyphen the variable equal to the value. That's it. Nothing more than that. Okay. So I would recommend you to work on all these examples which I explained you today. Let's have a quick recap of what we learned. In today's session, we learned about the landscape. We learned about R3 structure, and we learned about the landscape. We learned about the control statements like we learned about if, end if, else if, and we have some example on that. And also we learned about case, end case. We learned about psi hyphen index, the system field. We learned about do loop, do end do, unconditional loop. We learned about breaking the condition with the help of the condition. We have broken the loop with the keyword called exit. We learned that, and we have seen the examples of these control structure statements. And just now I told you about the example of structure also, like how do we declare structure, all those things. We have seen this example here. I mean, this is the example that we have seen over here. Okay, so you have pretty much content available for you to practice. And I would say you to practice more, not only this, which is explained you in the class here. I want you to do more on your side to get addicted to the learn. Okay, so let me explain you about internal table also. I'll explain you quickly. Okay, let me put a breakpoint over here. Let me put a breakpoint over here and try to execute it. Are you able to see my screen? Okay.
Yeah.
So if you see this, observe here. What is the first record? First record name is Capitec India. Let us suppose. But if you see here, you are able to see the second record details in the end of the program. In the end of the program, you see the data related to the SAP India only, not related to the first record. It means every time the content of the structure will be overwritten. It means up to here, it will be one record. When it crosses this, immediately when you assign some new values, the old values are gone. You cannot retain those values here. I mean, you cannot retain the old values. So I want to even see the old values also. How do I do that? Even I want to see the old values. So if I want to see the old values, then what you need to do is you need to define an internal table. You need to define an internal table. So I'll tell you what this internal table is. So first, let me explain you how to declare it. So I say data lt underscore std. I'll say like table of struc struct underscore student. I'll tell you what is this. Just activate this. Okay. So just try to observe, try to understand this syntax. I declared a variable called lt underscore std. L stands for local, T stands for table. Like this is like internal table, std, like table of struct underscore student. It means this is a struct underscore student. Struct underscore student is the structure. It means I want this lt underscore std to be a table, like the structure of the table should be struc underscore student. The structure of the table should be struc underscore student. So what does this mean? Very simple. I'll put a breakpoint here. Just execute it. Okay, we'll see what happens in this LTSD. Let us see. Let us open and see what that LTD looks like. Double click on this LTD STD. Okay, LTSTD. Just click on this. Try to observe what is this. See the fields: LV name, LV class, LV section, LV address. Are you seeing this?
Yes.
What you noticed? What did you notice? My question is, what did you notice? I said LTSTD and this LV name, LV class, LV section, LV address. Sorry?
It is in table form and also with data types.
It is in table form, correct? You can see here, see there is no data. That is the reason why you are seeing this value as 0. 0 is nothing but 0 records. This 4 is 1, 2, 3, 4. 4 columns. 4 columns. 0 records with 4 columns. Now let us try to see the row number is empty. Now let us what we will do. We'll try to put the data into the internal table. Now we'll come to know how to put the data into the internal table. Very simple. At this line, what I will do, append structure to internal table. So what I will say here, append struct underscore student to lt underscore std. Let us see. Okay. I'll put a breakpoint over here. What I'm trying to do, I assigned the values of all the fields into the respective field, into the structure fields. And this record, I am putting into the, I am appending. You see what I'm doing? I'm saying append your structure to internal table. Append your structure to internal table. So execute it. And let us see. This internal table concept is very important. Now let us see first. Generally for internal table, we will use these square brackets. Hit enter. Double click on this. You see this? It is empty, right? It is empty. Now what I'm trying to do, just try to understand this one. You see this is 0 records. Now I am at the line number 60. I press F5. You just observe here. Observe here. What happened? One record inserted into the internal table. Double click on this. You see the first record, row 1. You see the value of the first record. You see, you're seeing these values here in the internal table. Yes, we are seeing it. So it means we are trying to hold the records of the structures. So what I will do, the same statement I will use at the, I'll use at, where I will use? I'll use at the end of this second record. I'll use at the end of the second record. Are we clear? Are you following?
Yeah.
Are you following? Any confusion, any doubts? Any doubts to anyone? See what I did here? I declared internal table. I said data, internal table name, like table of. When I say table of, this will become a table. What kind of table? The table will have the structure same like this structure. Same like this structure means it will have LV name, LV class, LV section, LV address. That's it, simple. And you are assigning the values and you are appending it. How to append? Append your work. We call it as a structure to LTSTD. Generally, we call this as work area. We call it as a work area. In the next examples, we will pronounce or we call it as a work area. So as of now, we will say it as structure, but in the next classes, we will try to say this is a work area. So append this structure to internal table. Gone. Next, second record. Append your structure values to the internal table. Now, how many records are there in the internal table? How many records are there in the internal table?
Two records.
No, two records.
2 records. Only 2 records, right? See, one is with this Captic India, the other one with SAP India. That's it. Only 2 records are there in the internal table. Okay. So now I want to print data from internal table. Internal table. Let us suppose now 2 records are available in the internal table. I want to retrieve that data. So what I will do? Now comes the concept of loop. Loop at where is the data available? Finally, where is the data sitting?
Internal
Finally, where is the data sitting? Where is the data? Internal table. So
LT.
LTSTD, loop at internal table. Loop at internal table. So one more thing you need to understand here. When we have some data, let us suppose these are the records. Now, where is the data available? In the internal table. Okay, let's try to understand these two things. Let us try to understand this thing. Okay, this is very important, guys. So first thing, how did we put data? Okay, let us suppose these are the fields. These are the fields. What is the first field? Name, some class, name, class, some section. Okay, so let me remove this. I'll try to put it here. I'll try to put it here. This is our column. These are all columns. Okay. So now what is the first field? First field is what? Name, correct? Next is what? Class. Next is section. Next is address. The same thing you have here also, right? The same thing, whatever is there over here, whatever you have here, the same thing, the same column names are present here. Name, class, section, and address, let us suppose. Okay. This is how also you see this over here also. The same thing you see even here also. This is for your internal table. Guys, this is the internal table. The right side one is the internal table. And what is the left side one? What is the left side one? This is, what is this?
Structure.
Exactly. This is structure. Let us also call it as work area from now only. Okay, we call it as work area. And what is this?
Internal
What is
table.
this on the right side?
Mhm.
Internal table.
LTSTP.
Okay, now let us try to understand very much clearly. What are you trying to do in the program? You're trying to fill the data in the program, correct?
Yes.
You are trying to fill the
Mhm.
data in the program. What is the data? Let us suppose name. I'm saying Siva Krishna. Class, BTech. Section, let us suppose A. Next, address, I'm saying HOD. Okay, let it be. What next? What is the next step we are doing? What is the next step we are doing?
Appending.
Exactly. We are appending. We are using append. What do you mean by append here? Append to where? Append to
Internal table.
append from where to where? What
From
is the
work area
source?
to
What is the target, guys?
Section.
work area to internal table.
Exactly. Work area to internal table. I will say, I'll prefer saying work area to internal table. Okay? Work area to internal table. Are you so far with me?
Yes.
Mhm.
No, I mean, I am here, you are there. Okay. So, yes, you are so far with me. What I'm trying to do, I'm appending the work area to the internal table. Okay. So, when I say append the work area to internal table, what happens now? What happens? What should happen? What should be the results? The result is the first record, whatever the first record is there, this first record should come and sit into your internal table here. Are we good?
Yes.
So you filled the data, you are saying append work area to internal table, that data will come and sit into your internal table. Clear?
Yeah.
When we say append,
Yes.
this data will go and sit into your respective internal table. Okay. What next we are doing? What next? What is the next thing what we are doing? After appending, what we are trying to do again?
Adding new data to
That's
work
it.
area.
We are trying to add new data. Let us suppose I am saying here, okay, I am saying here some Ramakrishna, Ram K, BTech A Hyderabad. So again, what I am trying to do, I am trying to append that record to the internal table. So in this case, what happens? The data will come and sit into your internal table. Is it okay? Are we good?
Yeah.
Okay. So two things you need to understand here. The very first thing is, while you are putting the data into the internal table, you are filling the work area and appending internal table. Is it correct? That is what we are doing right now, correct? Second, when you get data from internal table, first get the data into work area and print. First statement you know already. You are very much familiar now. Now try to understand the second statement. Try to understand second statement and explain me. Anyone? Tell me what is your understanding in the second statement. That's it. While we are doing two things. One is this, the other one is reverse. When you are doing the reverse, same thing you need to follow. While putting the data into internal table, we fill the work area and then append, and then it goes and sit into the internal table. Now, next thing, when you want to fetch the data, you are fetching the data, put the data into work area. Put the data into what? Work area. Then you print the data in the output. That's it. So for accessing all the records of the internal table, you will use loop. Simple. For accessing all the records of the internal table, you will use the concept of loop. In the loop and end loop, you will actually use the print statements. So that is what I am trying to do in the program. Look here, loop at internal table. Yes, I am looping at internal table into what is of my work area name? My work area name is struct underscore student. So what happens now? Struct underscore student will have the first record. I am simply printing that in the output. That's it. Whatever the values are there in the structure, I am printing that in the output. That's what I'm trying to do. You see this? Okay. Now I am putting a breakpoint over here. Now try to execute. Just see the first internal table. It is 0 records. First record will insert. I am saying append. First record will insert. You want to go and see. Double click on this and see the first record. Yes, it is there. Now go back to. Okay, look here. When I click on this, you are here. You will be able to see this data. If you want to go back to your program screen, click on desktop 1. Click on desktop 1. You will have the screen visible over here again. Now, I put a breakpoint here. I can directly put a breakpoint in my debug environment also. I can put it anywhere, everywhere you want to put, you can put it. I mean, only at the executable statement you can put executable statements. Now, I press F8. Now you are here. Now press F5. F5. You see now second record inserted into the table. Double click on this. You see the second record will be there over here. See the record that gets appended will be the last record. The first record will be as it is, and the second record will come and attach it to the existing record. Likewise, the process will continue. Okay. So now you will have the two records in the internal table. Now what I'm trying to do, you see this loop at internal table into work area. Just try to see what is your work area here now. What is the value you have? The latest value is what? SAP India. So the best practice is always, you have to clear this work area as and when you complete appending. You need to clear the work area. You should make these fields empty. So how to do that, I'll let you know. But before that, try to look into this. Now press F5. Now if you see If you see, now I executed the first record of the internal table. What is the first record? Capitec India. Okay. You will see in the structure the first record details. You see, you will see the Capitec India details in the first record as a first record. Okay. So that data will print in the output. We will not see that printing, that will print in the output. Next, I press F5, second record. Now see the second record contents in the structure, SAP India. Okay. So now those contents will be printing in the output. And execute it, you will see two records. Okay, guys, is it clear? And what I said is, every time you say clear this work area, always after append, always after append, try to clear your work area. If you are not clearing work area, what happens? I will tell you. Okay. So here, what I will do, let us suppose I'm not clearing work area. Okay. If I'm not clearing work area, I'm trying. Okay. So when you say clear work area, what happens? Let us see. Let us see in the debug. In the debugging mode, let us see what is the effect of that clear statement. I put a breakpoint here, execute it. I think I have placed this breakpoint at the wrong place. It should be after append. But anyways, you see these values? Okay, there are values, right? When I say clear, press F5, all the values are gone. All the values are gone. When you don't say clear, all the values will remain. So it's the best practice that you clear the values, because you are using this for multiple purposes. You don't want the previous data to combine with the present data. What does that mean? I'll tell you. What does that mean? I'll tell you. So now what I will do, just for your understanding, I appended the data here. Let us suppose. First record I appended. First record I appended. Now second record, I am not using clear statement. In the second record, LV name, I am not assigning the value of the LV name. Okay, I commented the data. I commented the data. Let us see what happens in this case. Are you following? What I'm trying to do, first record I appended it to the internal table. In the next section, I need to assign the value to LV name, but I'm not assigning the value for the second record. I'm just commenting this line, but I'm assigning class, section, and address. What will happen to LV name in this case? Any guess?
It'll stay the same. Capitec India.
That's it. It will have the same values. So just try to see this, how it looks like. So that is very dangerous. I mean, not clearing work area is the very dangerous thing. So you see this. First record is appended. You can see Capitec India. Now I'm coming to the second record, guys. If you just observe here, but still we'll try to see what is the value of LV name. See what is the LV name? Capitec India only. What is class? Section? These are all old values only, but even though there is no difference between the previous and present, so you will not find any difference. But let us try to see the LV name. What happens to the LV name? What happens to the second record? Okay, second record inserted, you see. Second record also has the name as the first record, which is not correct? So if you're not clearing, it will retain the values, it will hold the values, and it will advance to the next level. So that is the reason why I always say, try to clear your work areas as and when you complete your complete your append structure. Append structure is done, you try to clear your work areas. Any doubt in this program or example explanation?
Mm.
So day by day, the concepts will increase. So the reason why I explained you about this internal table is you will have time up to the next weekend. You can practice more. You can have more practice on this and try to try to build some examples on your own and try to have this programming the programming styles adaptability. It means when you practice more, you will have more more knowledge of the concepts. Yeah, that's all for today's session. Any doubts in this program? In this structure, we define what we did here. We defined a structure. This is the syntax for structure. And then we assigned the values to the structure, and then we printed the values. That is one thing we did. The other thing is, for this structure, we created the internal table. We assigned the values to that structure and appended the structure values to the internal table. Same thing we have taken for the second record. And we introduced a new concept called loop at internal table into work area. And guys, also remember, here also you should try to clear your what? You try to clear your work area. Here also you try to clear your work area. Inside the loop also try to clear it. Wherever you are using it, after the first use of that work area, try to clear the values. Okay, so here also I am clearing it. So in the loop at internal table into work area. So record by record, the data will come in, sit into these respective fields, and that will get printed in the output. And remember, LTSTD belongs to this structure. Now what I will try to do, I'll try to take one more structure, struct student 1. I'll try to introduce one more field over here. I'll say LV address 2. Okay. And this is, I make it as a structure 2. Okay. Activate it. Both are different now. Both are different structures. Something went wrong. Okay. What is that? What is that? What is that? What is that? What is that went wrong?
Begin is student 1. We had to change it to student 2.
Yes, student 1. It should be student 1 only. Yeah. Okay. So now you see, both of them are different, guys. Do you think both of them are same structures? I'm asking the question, student 1 and student, both are same or not?
No,
Why?
because we have added an extra field there, LV address 2,
Okay,
and that is absent in student 1.
that's it. It is present in student 1, it is not present in student. Okay, so there is a difference. Even though one difference is there, it is different. Okay, even though extra field added, it's different. So what I'm trying to do, this struct student 1, I'm trying to put it here. Let us suppose, look here. I'm trying to put it here. What I'm trying to do, I'm trying to put this here. Let us suppose as a first field, because I want to have some difference in the fields. You see, there is an error. What is the error? Let us try to see. Struct student 1 cannot be converted to the line type of LTSTD. What is this? Struct underscore student 1 cannot be converted to the line type of LTSTD. I'm taking a screenshot of this just for our reference. Now, what does this tell you? What are we trying to do? Just try to understand this one. What are we trying to do? Can someone explain what is the issue here?
We are not giving the right statement. That address
You're not giving the
in right statement, we are not giving that address to.
We are
Uh,
giving it, right? No, it's
yeah.
optional. Whether you print all the fields or not in the right statement, it is optional actually.
Okay.
It is optional. Whether
I
you
think
use or don't use.
we missed one full stop there
Where?
near loop at statement. Okay.
What I try to do, I commented this structure underscore student. I introduced a new structure here. Followed. What is a new structure? Student one. Student one is this. Student one is this.
It has an extra field address
Okay. Okay. So what?
so it cannot loop into this one.
Why there is error? First, my question is, why is this error? Struct student one cannot be converted to the line type of LTSTD. What is line type of LTSTD?
Internal
Line type
table.
means what?
Internal.
No.
We have created an
LTSTD.
internal table with using student,
Exactly. Yes.
but we
Correct.
are using student one for looping.
Exactly. You are right. You are right. We LTSTD, we built LTSTD basing upon what is that we are using here? Okay, now I am removing this. Okay, just for your understanding. Let me expand this now. So just try to understand, guys. For building this internal table, which structure I am using? I am using LT, this student structure I am using. Okay, it means when I am using loop, not only loop, when I am appending also, I need to have the same structure. Whatever that I used here, the same structure I can use for my append. I cannot use student one here. Just see, I cannot say student one here to append to LTSTD because LTSTD has this content and student one has this content. Both of them are mismatching. Are you following? So, are you following or I'm confusing you or you're getting confused?
If the fields are matching, will it work for student
If
one?
fields are matching, it will work.
Okay.
If fields are matching, it will work. For example, I'll take this. I'll make it as student 2. As it is, I will make it as student 2. Okay. Any change in this except the structure name? Is there anything change? No change. If you observe here, std2 is also same like student. Student 2 is also same like student. Both are same. There is no change. Fields are same. Only the structure names are different. Fields are same. The structure names are different. So let us see what happens in this case. So I try to activate. It got activated. And if you observe here, execute your program. Just execute it. You will see the output. You need to change this. Just I'm changing the fields. Execute it. See the output. So there is no problem until unless the internal fields, their data types are same. Even though the structure names are different, that doesn't matter. It should match the internal contents of that structure. That is a basic information. Okay. So what I tried, I used internal table building with reference to this structure. And in the loop at internal table into work area, I am using a different structure with the different fields inside it. That is a problem. It was throwing the error. Okay. Any doubt?
No doubt.
And others? What about others? Anybody has any kind of confusion?
What if we change field name alone? Data types will be same.
Sorry, come again.
What if we change the field name alone, but keep the data types matching?
What if we change the field names alone? Okay. I'll say name 2. Okay.
Okay.
Let us suppose it is name 2. Now here I will say it as name 2. Let us suppose. Activate it. No error. Let us see what happens. If data type is same, there will not be any issue. If data type changes, there comes the issue.
Okay.
You see? You still
so
have
only
the
number of fields should be same and data type should be same.
data type, the fields data type should be same. That's it.
Okay. Okay.
Now, for example, I will change this to, let us suppose, I will say this as integer. Let us suppose. Even character also it will accept only up to some this thing. I'll say this as I. Let us suppose. You see, there is an error. Student cannot be converted to the line type of LTSTD because your internal table is referring to this. In the loop at internal table into work area, you are referring to, sorry, your structure is built, your internal table is built with respect to student, this one. But in the internal table, you are referring to this. So what is happening? LV name 2. It will compare the data type. It is string here, it is I here. No, it is not possible. Even though fields are different, their data type should be same. Data types must be same. Okay, but we always see the fields names are same along with the data types. Clear?
Yes, sir. Understood.
So these kind of things that you need to do, whatever the questions you are asking, you need to put yourself, yes, okay, now I will change the data type. Now I will change the length. I will change this to character. I will do my, what is this? This fields up to upside down, downside up. Likewise, you'll make it as like zigzag, not in order. So what happens in that case? So likewise, you need to practice. That is what I told you. So you have to practice in all the ways. Whichever the doubts you have, you just try to put and see. You'll come to know whether that is possible or not possible. Okay, so this is very important. This concept of internal table is very important because what we will try to do, in the next sessions, we will try to build the program for fetching the data from the database table, and we will push the data into the internal table. We'll write a program to get the data from the database table and put that data into the internal table, and from there we will do the appending in internal table or deleting the table records or modifying the records of the table. All those things, that internal table operations, we will do it. Okay, so this concept is very important. So that is the reason why I wanted you to focus more on this. In these internal tables, there are even some types that we will come to know later, but the basic understanding is this. Is it clear?
Yes, sir.
Okay, so that's all for today. If you have any